Hi everyone, my name is Greg Willis and I work at Dataiku. I'm the Director of Solutions Architecture. Welcome to this presentation. Thank you very much for attending. I'm just going to start off with a few slides and then we're going to move over into a demo. So first of all, Dataiku is a global ISV partner with Microsoft, have been for many years. Recently awarded the Partner of the Year award in the France Intelligent Cloud category. I'm going to step you through a little bit about what Dataiku is, how we work, some of the technical details and the architecture, and then switch over to a live demo to show you some of those features. So what makes Dataiku unique? You can sum it up in one sentence, in that Dataiku provides scalable, end-to-end, multi-persona collaboration in a single product, which means scalable data preparation and machine learning processing for thousands of users, end-to-end AI ML lifecycle management, supporting multi-persona users from no-code business analysts to full-code data scientists and everyone in between, with real-time collaboration between those users, and all in a single ready-to-use product, which is called Dataiku DSS, Data Science Studio. The individual elements are not unique, but the combination of them in a single product is. For example, you can find other products in the AI and ML space that give certain end-to-end capabilities, but usually within different products that are broken out and they have to be integrated together with different interfaces, and they're usually targeted at different personas. Collaboration too has been a core part of Dataiku from the beginning, but these days you can find pretty much everybody using that word. But what does it really mean? If you dig into it, it's typically about an individual sharing an asset, such as a model or a notebook, rather than true real-time collaboration that you find in Dataiku. To give an example of the difference, the former is like creating a PDF document on my laptop and putting it in a network drive and changing the settings so that a colleague can come and read it and make a copy and use that document. The latter is more like a Google Drive doc or something similar, where multiple people are all working together in real time, editing, commenting, adding, deleting, and actually increasing the quality of the asset and the speed at which it can be created. So building and delivering AI at scale requires integrating dozens of technologies to seamlessly work together across multiple domains, providing features within data, machine learning, operations and platform and infrastructure. Dataiku DSS is a ready-to-use full-stack data science platform in which all of these different technologies, from things like Python and Kubernetes to Jupyter Notebooks, are already integrated. Our joint solution puts Microsoft at the center of this technology ecosystem and thus makes all of Dataiku's capabilities available to Microsoft users and the power and scalability of the Azure cloud available to Dataiku users, including no-code, low-code, and full-code users, SQL-focused users, plus architects that may need to use multiple languages and tools. So how can you actually deploy Dataiku? There are three different ways. The first is a fully managed self-service offering called Dataiku Online for small customers. The second is Dataiku, a custom option, Dataiku Custom. This basically is if you have an on-prem customer or maybe a customer that's on the cloud, but they want to deploy into their own tenant with their own specific requirements, perhaps around security or other things like that. The third is Dataiku Cloud Stacks, where we provide a way for customers to automate management of all of their Dataiku DSS instances in their own cloud subscription. But what is data science anyway? So let's take a step back. You can find a lot of Venn diagrams on the internet for pretty much everything, including data science, but this is the one that most closely matches my own thinking. For me, data science is an interdisciplinary field which combines business expertise, computer algorithms, and statistical methods to extract insights from various data sources. Most typically, it does this by using supervised machine learning algorithms to train models using patterns in historical data, for example, house price fluctuations or activities that indicate financial fraud, and then uses that model to make predictions on new data. Dataiku manages that entire data science and machine learning lifecycle, starting with the iterative design phase through deployment and automation in production systems, all the way to monitoring and feedback. And this whole process is often called MLOps. The main node type within Dataiku is called the design node, which is where most of the work happens, connecting to data, exploring, analyzing, training machine learning or deep learning models, etc. Once the project is complete, there are two further node types that support operationalization of the project, or perhaps individual models, which are the automation node for batch scheduling and monitoring, and the API node for real-time, REST-based machine learning API service deployments. So what does that mean? How does Dataiku integrate into a Microsoft ecosystem, for example? Well, you can see Dataiku providing the end-to-end capabilities necessary for a single integrated data science platform. But we have a lot of integration points with Microsoft services all the way along that process, from integration into Teams, for example, to extend into external collaboration capabilities, using SharePoint for document sharing, Visual Studio Code as an alternative IDE. Dataiku comes built in with its own Git repository, but you can also integrate into external ones like GitHub. You can extend the visualization capabilities of Dataiku by integrating into Power BI. And on security side, we integrate with Azure Active Directory. But where we really take advantage of the full kind of power and capabilities of Microsoft Azure Cloud is in the compute and storage layers, where we have a very tight integration into Azure Kubernetes service. We use that as a multi-purpose computation cluster for Python, for Spark, for R, for API service deployment and scaling, many other things. We also integrate into Azure Synapse, Azure SQL, into cognitive services to extend pre-built machine learning and deep learning capabilities. And on the storage side, various things such as OneDrive, blob storage, ADLS Gen 1, Gen 2, etc. So now I'll switch over to a demo. And we'll just come out of this. So hopefully that's come through correctly. What we can see here, if you're still with me, is the home screen of Dataiku. When you first log in, this is kind of what it looks like. You can customize this, but essentially what you're seeing is a list of your projects. And Dataiku being a collaborative platform, each of these projects would have a team of people that are working on it. And each project would typically be about a particular use case. So we have lots of different use cases here represented by the different projects. I'm going to open up this one here, which is about predicting churn. And specifically, this one is built on telco data. So we're looking at historical data where we know which customers churned. And what we'd like to do is use that data to actually gain some value from it for our business. So for example, we could predict which customers are likely to churn in the future, and then prioritize those customers based on perhaps how valuable they are to us, so their total value and the potential lost revenue if they did churn, and then feed that data into a downstream CRM system so that they can prioritize a certain action to take. Maybe for the very high value customers, they'll call them on the telephone directly. Maybe for medium value ones, they'll send them a voucher via email or something like that. So what you see here is the project home screen. You can see some contextual information about the project. You can customize all of this. There's a built-in wiki, etc. You can add links and things. So if I'm a new team member coming into this project for the first time, I can find everything that I need to get started straight away. You see some summary information like data sets and models and notebooks and stuff like that. I can have a to-do list. I can have a timeline here of my activities, so I see a summary of things that have maybe changed recently. I can also start discussions. I can send messages to other people in the project and tag them to ask them to maybe look at certain things or update something for me. I can also see things like the activity, the history of the project, so who's been working on what, and even say a punch card to see when people were working on it at different times of day and things like that. And as I mentioned before, Dataiku comes built in with its own Git repository, so everything is tracked and versioned, and you can go and see all of the changes, and actually even down to the diffs in individual files, so I can see which things have changed. And I can even, for example, create a new branch from a change, or revert a change of a particular file or of a particular version of the project itself, the whole project. But the main view that you have within Dataiku is the flow. So I'm going to go to the flow. And what you see here is a visual representation of all of the steps that have been created as part of this project. And as we saw in the presentation, data science is an iterative process where you're going to connect into multiple data sources. You're going to need to probably cleanse that data, aggregate it, do common types of transformations, such as maybe pivoting tables or running data cleansing jobs and things like that. You might need to use different technologies. You might have some users that are going to use primarily visual interfaces, and some users that are going to use different types of programming languages. And then you're going to use that cleansed and enriched data to build your machine learning models. So let's take a little step-by-step walk through all of those different steps. What you see on the screen, these blue squares, are data sets, and these can represent basically any kind of underlying data source. So in this case, we've got data which is stored in Azure, and that could be within Azure Blob Storage. It could be in Azure ADLS Gen 1 or Gen 2. It could be using a HDFS type of file system access on top of Azure Storage. We've also got a table down here from an SQL type of database. This is actually running on Synapse. And then in between the blue data sets, what we have are yellow visual recipes. So these are recipes that are pre-built into the product, ready to use straight away. And these are for completely no-code users. So if you're a business analyst or a citizen data scientist, or even a data scientist that wants to be able to get up and running very quickly and maybe iterate something, build an MVP without having to get into the code, these are very quick and easy ways to do very powerful data transformations. So you have all of the common types of things that you would want to do, like stacking and pivoting, etc., joining data sets together. And you can choose where things happen. So if your two input tables are an SQL table in Synapse, for example, you can choose to actually run those in database SQL, meaning that although you do everything visually, behind the scenes, Dataiku will transform your visual operations into native SQL, and it will push it down to run in the target system. You could also choose to run it on Spark if you have a Spark cluster, and Dataiku can actually provide that Spark cluster for you in a completely seamless and managed way. So if you don't have a Spark cluster, we can actually make that a very simple and easy option to use as an alternative data processing framework. The other thing that you see here are the orange recipes, and you have code recipes. So for example, this Python recipe here. This is a way to directly add or write your own Python code or R code or Spark code, etc. You can see we've got support for quite a few different languages. And you don't have to choose one or the other. You can see in this flow, for example, there's a straight Python code recipe. There's also a PySpark code recipe. You can have an R recipe in here, some SQL stuff, a command line piece of script or something like that as well. So all of the different users can use the tools and the interfaces that are appropriate for them and their role, but still work together and collaborating in real time within this same project interface. So what we have here is some data preparation steps, as I said, preparing the data. And then what we've got here is a table, which is kind of classic telco data, the telephone numbers and the state and things like day charges, night charges, evening charges, international calls, things like that. And finally, because this is the historical data that we're going to use to build our model, we also know whether these customers actually churned or not, so we can see which ones it was true for. And now we've cleansed this and we've standardized everything, enriched it. The first operation we're going to do is this machine learning recipe here, the green recipes, to train an unsupervised clustering model. So in this case, we're using k-means. And you can do that in a completely AutoML way within Dataiku. So if I open up here, you've got this lab button here. I can go down to the lab tab here and actually see I've got AutoML clustering. I've also got AutoML for prediction and deep learning prediction as well. And you can go as kind of shallow or as deep as you want. So if you're a completely no-code person, you can go down a completely no-code route and just use visual and AutoML interfaces. However, if you are a data scientist that wants to code and you want to kind of go into expert mode, you can do that too. If you've built custom Python models, and you want to bring those into the platform, you can also do that. So we've run this, we've trained this model here, and then we've scored our data on it to apply labels. So I can see, for example, now within this data set, as well as the churn information, I have a cluster value from where I've applied that k-means model. The next step is to then actually train a predictive machine learning model. So here you can see I've got a prediction model, which is a random forest classification model to predict either churn or no churn. And if I open this up, what you can see is I've got one version of this. I could have had multiple versions, and it will tell you which one is active, and you can switch between the current one and previous ones, drill into the details of previous ones, so everything is saved and versioned. And if I go back to the original analysis where this model was actually created from, I can see all of the historical settings that we used. I can see the different sessions where we ran our different experiments. So this was the latest one, session 2. We saw that the one that we actually deployed, excuse me, was the random forest. But actually, the XGBoost had a slightly higher score here. And Dataiku is a completely white open box solution. So you can go into the design tab at the top here and see all of the settings. So even if you choose to go down an AutoML path where Dataiku will do everything for you, and you don't need to see any of these settings, you can still go in and open them up and have a look and change them and rerun it. So maybe as a citizen data scientist, I want to come in and see what settings have been set here. I want to see how we're handling the train and test data set. Maybe I want to override some of those settings. I can see how it's handling the features automatically. Again, I can go in and do that and change things like imputation of missing values or the variable type, etc. Do feature generation or reduction, or I can override which algorithms it's chosen to use. So Dataiku, if you do AutoML, it will intelligently choose a few algorithms to test, and it will set default parameters. But maybe I want to come in here and choose a different one. Maybe I want to run a logistic regression, and I want to change some of the parameters in here. I can do all of that. And then I can rerun this, and it will generate a new result for me. Once I'm happy with a particular model, for example, let's say this XGBoost one, I can go in and look at the particular details of that. So I can see things like variable importance, look at partial dependency between variables, look at subpopulations. So is my model actually fair? So in order to combat machine learning and AI bias, I need to analyze my model to make sure that it's behaving fairly across all populations of my data. Maybe for regulatory reasons, I might need to explain individual predictions, so I can do that too. And then you get all of the typical tools and things that a data scientist would use to evaluate the performance of a chart. And if I was happy with that, I would then deploy it back into my flow. So you see the deploy button up here. I would click that, and I could have multiple models deployed into my flow, but I'll just keep it at one for now. And we can see that other people are actually connected to this platform at the same time as I'm demoing. So just to kind of emphasize the real-time collaboration aspects here. And then the output data is our data set with our prediction value appended, and we can see even the probabilities here as well. So we can now use this data, perhaps the value that this customer currently generates, multiplied by a probability of them churning, if they're predicted to churn, to get a potential revenue loss. So we can use something like the prepare recipe in Dataiku, which is a general purpose and very powerful recipe to do custom data preparation, data cleansing kinds of tasks, but again, without necessarily needing to write any code. So you have lots of built-in processes here to do different things, geographic operations, mathematic operations, data cleansing, natural language, etc. But what I'm going to do is just replace these values, turn them into numeric. And then I'm going to run a short calculation here, an expression, to actually convert that into a value, which I can see over here, which would be the kind of weighted charge that we would be potentially losing if this customer did churn. So we could use that to then send that data out to a system, a different system, where it would get picked up by perhaps that CRM system downstream, so that somebody can look at the highest value customers and prioritize those for outreach. Well, that was a very quick tour of a single use case in one project in Dataiku, but hopefully that gives you at least a bit of an idea and a bit of a taste for what Dataiku can do, particularly within the Microsoft ecosystem, working with things like Azure Kubernetes Service to scale out machine learning processing as well as data processing, being able to manage Spark clusters on top of Kubernetes and use Docker environments, containerized environments, integrating into underlying compute and storage options such as Synapse and SQL Server and Azure Blob and ADLS Gen 2, and also being able to use things like cognitive services to perform sentiment analysis and other types of natural language processing, so language detection, entity recognition, etc. Hopefully that was useful. Please come and find us again. Thanks very much. Bye.